Now, this is very important figure. This figure is used for designing the aeroplane, space shuttle, rockets, ballistic missiles, etc. In this figure, we have a atmosphere at different altitude. Starting from surface, we have a 0 kilometer, then 10 kilometer, 20 kilometer, 30 kilometer, 40 kilometer and 50 kilometer in atmosphere. And on x axis we have temperature. We are starting from plus 20 degree centigrade to minus 100 degree centigrade, and here we have a 0. So, on x axis we have temperature and y axis we have altitude, and this is the ground surface, sea level 0. So, up to 10 kilometer, this atmosphere up to 10 kilometer is called troposphere, and from 10 kilometer to 20 kilometer is called stratosphere, and again that we have further division, but we are not going to discuss that much. Up to 10 kilometer it is very interesting, because up to 10 kilometer we have observed that as we go upward, temperature is continuously reducing. So, this linear, there is a linear relationship. So, linear relationship is defined with the help of T, where T is function of Z is equal to T naught. T naught means temperature at the sea level minus beta into Z. Z is altitude. Beta is known as a temperature lapse rate. So, as we go upward, the temperature is continuously reducing. This temperature should reduce at this level, 0.00650 degree Kelvin per meter, right. So, if temperature is reducing at this rate, temperature lapse rate, then system is, or our weather is stable. If temperature, because of some local region, if temperature is not reducing there with this temperature lapse rate, then our weather becomes unstable, and if weather becomes unstable, then it will lead to flow of winds, and this flow of wind may create any kind of pleasant situation or unpleasant situation for mankind, depending on its severity and depending on its location. So, this is very much important from weather forecasting point of view, and the temperature outside the altitude beyond 20 kilometer is very much interesting for our space shuttle and missile technology, because we know that though outside temperature at 50 kilometer the temperature is minus 2.5 degree centigrade, but when a space shuttle enters into this atmosphere with very high velocity, then temperature goes very high, and if we do not control this temperature with the help of suitable materials, then we will have a unpleasant situation. Because of that, several accidents took place, and in which in one of the accident the Indian astronaut called named Kalpana Chawla was also killed, because that space shuttle was entering into atmosphere, temperature was going very high because of the velocity. We know that static temperature at that level is minus 2.5 degree centigrade, but since object is entering with very high velocity, then stagnation temperature of the surfaces of this space shuttle went up very high, and that led to that accident. So, we must develop a suitable material to withstand that temperature, and to understand that how much would be the temperature for corresponding velocity, we must know this figure, and with the help of this figure only we can find out what would be the corresponding temperature for that velocity. So, either we control the velocity with which the space shuttle, rocket, missiles are entering into the surface, or if we can't control the velocity, we must develop a suitable material which should be able to withstand that temperature which is going to develop for corresponding velocity. Now, from 10 kilometer to 20 kilometer, this variation is isothermal and we have a constant temperature, right. So, if we have this temperature variation as in a 10 kilometer zone, T is equal to Ta minus beta z, then correspondingly we can substitute this value here and we can integrate and we can find out the pressure variation also. So, we can write the pressure variation equation and correspondingly we can develop the figure for the pressure variation with altitude, that how does pressure vary. This is the pressure on x axis and altitude on y axis. How does pressure vary with altitude?